Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Assalamu alaikum, dear students. In today's lecture, we are going to learn about the soil classification and soil classification systems. So first we will study about the classification of the soil. Then we will discuss about the older soil classification system, which are based upon the textual classification. We will solve problem 1 and 2 related to the textual classification. We will also discuss the limitations of the textual classification systems, which is the USDA, or US Department of Agriculture proposed a soil classification system which was based upon the texture. That will be discussed, and the limitations will also be discussed in our today's introductory lecture. In coming videos, we are going to discuss the modern classification systems, and those two systems are AASHTO soil classification system and unified soil classification system. Then comparison between AASHTO and USCS system will also be made, and at the end we will give you a summary of these systems. Now, soil classification is the arrangement of different soils with similar properties into groups and subgroups based upon their applications. Now, what are those similar properties? For example, talking about the compressibility of the soil. For example, we can say strength characteristics. For example, we can also say the permeability. Properties of these soils are based upon the soil classified in groups and subgroups. Now, based on the application, so we can use for foundations, we can use for retaining walls, we can use for dams, embankments, and so on. Now, different soil classification systems are available. So classification systems provide a common language to concisely express the general characteristics of the soils, like compressibility characteristics, strength characteristics, or the permeability characteristics, which are infinitely varied without detailed descriptions here. Most of the soil classification systems that have been developed for engineering purposes are based on simple index such as particle size distribution and plasticity. We already discussed about the particle size distribution, sieve analysis, and hydrometer analysis in our previous videos, lectures, so you can refer to those lectures if you want to understand that how we do the particle size distribution for fine grained soils and also for coarse grained soils as well. We also discussed about the plasticity of the soils, like for example liquid limit, plastic limit, and shrinkage limit. So these limits, how we find out, we also discussed in good detail that how we can find out the liquid limit, plastic limit, and shrinkage limit. Now, a soil classification system represents in effect a language of communication between engineers. So when we are dealing with projects, so structural engineers, water resource engineers, geotechnical engineers, environmental engineers, they need a common language to talk about those soil particles, and therefore a system is needed to communicate between these engineers during that project. Now, therefore, by knowing the soil classification, the engineer already has a fairly good general idea of the way the soil will behave. Now, for example, if you find out that it's a coarse material, whether it's a fine grained materials or if it's a mix of the two, it will give you an idea about the strength, compressibility and permeability of the soil. That behavior you can relate to those three words. Now, the sizes of particles that make up soil vary over a wide range, but soils generally are called gravel, sand, silt or clay, depending upon the predominant size of particles within the soil. Now, to describe soils by their particle size, several organizations have developed particle size classifications. Some classifications are Massachusetts Institute of Technology, and you can simply call that MIT Soil Classification System. USDA, or the US Department of Agriculture Soil Classification System. AASHTO Soil Classification System, or the American Association of State Highway and Transportation Officials. US Army Corps of Engineers and US Bureau of Reclamation. They also proposed a soil classification system which can be used to classify the soils. Now, this table shows the particle size classifications. Name of organization is given here on the left column. Gravel sizes, sand sizes, silt sizes and clay sizes are given in millimeter. For example, if you are talking about the USDA system or US Department of Agriculture system, a gravel is a particle which is having size of greater than 2 millimeter. And sand is a material that is having a particle range of 0.05 to 2 millimeter sizes in millimeter. That would be known as sand, and silt are those particles having range of 0.05 to 0.02 millimeter. Anything less than 0.02 millimeter will be known as clay size particles. Now, when we see the unified soil classification system, now any particle which ranges in between 4.75 millimeter to 76.2 millimeter, that will be known as gravel. And any particle which ranges in between 0.075 to 4.75 millimeter, that would be known as sand. Now, USCS, or Unified Soil Classification System, classified the silt and clays together, and any particle which is smaller than 0.075 millimeter, those particles are known as silts, and clays particles are fines. Now, two major categories in which the classification systems developed in the past can be grouped as under. One is the older classification, which is based upon the textual classification, and textual classification is based on the particle size distribution of the percent of sand, silt, clay size fractions present in a given soil. However, the modern soil classification system, they take into account the particle size distribution and the Atterberg limits, for example liquid limit and plasticity index. Now there are two major classification systems in the modern classification system. This is the AASHTO system and the Unified Soil Classification System. Now let's discuss the older classification system, which is based upon the textual classification. Now, textual classification of US Department of Agriculture is based upon the particle size limits as described under the USDA system. So we already discussed here the USDA system, this one. Now the gravel is a particle which is having greater than 2 mm. Sand is a particle which is having 0.05 to 2 mm size. This range. Silt, anything between 0.02 to 0.5 mm will be known as silt size material, and anything less than 0.02 mm will be known as the clay size material. In the textual classification systems, the soils are named after their principal components such as sandy clay or silty clay. Now, texture of the soil refers to its surface appearance as well. Soil texture is influenced by the size of the individual particles present in it. Mostly natural soils are mixtures of particles from several size groups. Percentage of each particle size, for example sand, clay and silt, is denoted based on the percentage of each particle's soil type is determined. Now generally the term texture is referred wholly to the size characteristics of the soil particles. For example, large soil particles with some small particles will give coarse appearance or coarse organizations. The following figure shows the textual classification system developed by the USDA, and it is based on the particle sand is plotted at the bottom. So till 100% of sand is plotted at the bottom. Now different regions are divided. For example, this one will be known as clay. This one will be known as sandy clay loam. This one would be known as loam. Here we are having sand. Here we are having silt or the silty loam as well. Now we will solve a simple problem on it, then you will understand that how we can find out the soil classification based upon the US Department of Agriculture system. So we need to find the classification of the soil which contain 30% of the sand, 40% of the silt and 30% of the clay. Now what we can do, we can draw a line for 30% of the sand, 40% straight line from 40% of the silt, 30% for the sand, 40% for the silt, and 30% for the clay. Now you can clearly see that this region, this intersection point, lies in the region of clay loam, so the soil can be classified as clay loam. Now loam soils are best for plant growth because sand, silt and clay together provide desirable characteristics, leave spaces in soil for air and water to flow and roots to penetrate. So these are the desirable characteristics. Now you need to note that the chart on previous slide is based on only the fraction of soil that passes through the number 10 sieve having size of 2 mm. If the particle size distribution of a soil is such that a certain percentage of the soil particle is larger than 2 mm in diameter, a correction will be necessary. Now the following formula will be used. For example, we need to modify because we don't have any gravel percentage in that previous figure, so we need to subtract the percentage of gravel from 100%, and similarly we need to also modify the percentage of silt, modify the percentage of clay by subtracting the percentage of gravel from 100. Let's solve a simple problem. So soil B has a particle size distribution of 20% gravel, 10% sand, 30% silt and 40% clay. Now we need to find out the modified textural compositions. So for the sand size, we can simply subtract 20, which is the 20% gravel, and we will get the modified or corrected sand percentage, which is 12.5%. For the corrected or the modified silt size percentage, that would be 37.5%, and clay size, that would be 50.0% by subtracting the 20% of the gravel. So now we are having 12.5% sand, this dry line is 7.5% silt, and 50% clay. Now the intersection point lies in the region of clay, so hence from the USDA pyramid the soil is clay. Definitely there are limitations related to the textual classification systems, and they are based entirely on the particle size distribution and does not consider plasticity, which is an important parameter which to great extent influences the physical properties of the soils or general characteristics of the soils, for example the strength, compressibility and permeability of the soil. Now because textual classification systems do not take the plasticity into account and are not totally indicative of many important soil properties, they are inadequate for most engineering purposes. Now the two elaborate systems used at present are AASHTO and USCS. Both systems take into account the particle size distribution and plasticity. Now the AASHTO classification system is used mostly by highway departments. Geotechnical engineers generally prefer the unified system. So that's the end of the lecture or the introductory lecture on the soil classification systems. In the next lecture we will touch and we will study the modern soil classification systems. Thank you so much for watching the video, and I hope you are enjoying my videos. Please kindly like, share and subscribe to my YouTube channel. Assalamu alaikum and Allah Hafiz.